At a high level, XDR provides asynchronous replication of data across clusters. Since it is asynchronous, we are not tying the performance of one cluster to that of another. This allows the clusters to reside long distances from each other, even across oceans. XDR is unidirectional, which allows for finer control of how the data is distributed. A bidirectional replication is simply two unidirectional replications. As well, replication can be designated by namespace or set, giving further control of which data is sent where. In the diagram on the left, we see one namespace being shared in red, where it follows a loop between the 4 sites. There is also a second namespace shared in a loop between the 3 sites on the bottom, Ohio, New York, and Santa Clara. On the right, we have an internal view of some of the XDR components. The Aerospike daemon, ASD, invokes the digest logger when a write occurs. The logger inserts data into the digest log. Separately, there are 4 threads that manage the digest log: the digest reader, the source failure handler, the XDR client which communicates with remote clusters, and the destination failure handler. Here are some use cases. Disaster recovery, off-host backup, geographic distribution of data for locality of access, cold-hot storage with only a subset of hot data on the edge, but a central repository for cold data, cluster migration with limited or no downtime. For example, hardware or software upgrade, geographic relocation, or migration to cloud or bare metal. And finally, pub subtype data model using XDR's change notification feature.